Alright, so welcome back. So let's take a look at what we call the product and the quotient rules. This is how we can take the derivative when we are multiplying two functions together. That's called the product rule. So let's say we have a function, h of x, and it is the product of two functions, f of x and g of x. To get the derivative, now we're not going to worry about proving this, you can do that on your own if you get really bored, we are just going to give you the rule. So we have the first function, and g of x is my second function. So the product rule basically says this. You're going to take the first function, which is f of x, multiply it by the derivative of the second function. So we sometimes say this is the first times the derivative of the second. So I say first d2. Add to that the second function, g of x, times the derivative of the first function. So I go plus second d1. So this is our rule. Now you just have to memorize this. It's going to be amazing, okay? Now it's very easy to take a look at, to use. So let's take a look at examples 1 through 3 right here. Example 1, it has two functions. We have 2x, there is my first function, and we're multiplying that by cosine of x. And we want to do the derivative. We're going to do the first function. We're just going to write it down. The first function, f prime x, which is 2x, times the derivative of the second. Well, what's the derivative of cosine? We know that is negative sine of x. Plus, now we're going to write out the second equation, cosine of x, multiply that by the derivative of the first, which is 2. And you can leave it like this, that's okay. But we're going to simplify it a little bit. This becomes negative 2x sine x plus 2 cosine of x. And there is our derivative right there. Now, for number 2, we do have a problem. We don't like the square root of x. Remember we talked about that yesterday in another video. So we're going to write this as x to the 1/2 times the sine of x. And there we have our first function. And there we have our second. So when we're looking at the derivative now of g prime of x, we're going to take the first, which is just x to the 1/2, times the derivative of sine, which is cosine of x, plus the second, which is sine of x. And here's where the fun begins. We're now going to multiply that by the derivative of x to the 1/2, which is, use your power rule, 1/2 x to the negative 1/2. But please remember, we don't like negative exponents. No negatives. No negative exponents here. So my final answer, g prime of x, would be x to the 1/2 cosine of x plus, now there's a couple ways I can do this. This is just sine, the easiest way to do this is sine x times 1 over 2x to the 1/2. There are other ways you can do this, and if you look at the answer in the back of the book, they're gonna have it way simplified, but just leave it alone. All right, number 3. Now, if you try to work this ahead of time, there's a typo there. There should be no 5 there. So let's try this one. There's our first function, and here's our second function. So to get our derivative, f prime of x, we're going to take our first function, which is this x cubed times, what's the derivative of the second? Well, that's a power rule. 4x cubed minus 6 plus the second, x to the 4th, minus 6x. And I'm going to multiply that by the derivative of the second, 3x squared. Ran out of room. And there is our derivative. Don't simplify. That's our rule. Okay? Don't simplify. Just leave that alone. Unless you're like, Mr. Werner, I'm bored. My parents want me to simplify, so here you go. Don't do it. So that's the product rule. The next thing we're going to talk about here is the quotient rule. This is what will happen when we're dividing by function. Now there is a rule here. G of x cannot equal 0 for obvious reasons. We can't divide by 0. So here's how this works. It's kind of similar to it. It actually comes from the product rule, but we'll talk more about that later on. That involves another rule called the chain rule to prove this. So to take the derivative, we're going to go low. We're going to take the bottom function, g of x, multiply that by the top function, f prime of x, minus the top function, f of x, times the derivative of the bottom, which is g prime of x, all over the bottom squared. I have a very hard time remembering it this way, so I remember a little ditty. I say, so another way to remember it is low D high minus high D low all over low, 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 low. Just low squared. Low, low. Low D high minus high D low all over low, low. Low squared. Okay? So let's take a look here. Now, number 2, that's going to be a tough one. You're not going to like that one, okay? You're not going to like that one too much. Well actually, that's not too bad. There are one that you're not going to like. We'll talk about see those, I think, in the next day. All right, so let's say I want to take this derivative. Well, there's my top. There's my bottom. This is pretty nasty, okay? Just wait till we take the derivative. So f prime of x, I'm going to give myself some space here. The rule says low. So when I say low, I'm just going to copy it down, plus 13x squared times d high. That's going to become 2x plus 4. Please put that in parentheses. You need the parentheses there because we're going to multiply the distribution. Minus high d low. The derivative sign is cosine of x plus, that becomes 26x. That's my power rule. All over the bottom squared. Sine x plus 13x squared squared. There it is. Don't simplify. A lot of students really don't like quotient rule, but it's really a nice rule for us because we don't even really simplify anything. We just want to get an answer, and there's your derivative. That's nasty. That's like if your prom day came out looking like that, you'd be like, oh, go back, change. But that's my answer. We're sticking to it. So let's take a look at number 2. Same idea. There's my bottom. There's my low. And there's my high. So my rule, the bottom function, which is x cubed times the derivative of my top function, or low d high, cosine of x minus high, or my top function, d low, that's the derivative of my bottom, 3x squared all over the bottom squared. Now, this is okay to leave, but let's see what happens. I can simplify here. I can take this becomes x cubed cosine of x minus, I can just distribute 3x squared sine of x all over x to the 6. I'm okay leaving it like this. If you left it like that, that's fine. Full credit for that. But watch, I can divide this by x squared. You don't have to. You're going to get the same answer. This becomes x cosine of x minus 3 sine of x all over x to the 4th. Either one's okay. This is what the book will have. This is what you should have. I don't like this. Don't leave this, okay? The AP sometimes will want you to simplify. They want to make sure that you know your basic exponent rule, so don't leave it like that right there. Okay, so let's see here. Number 3. This is our derivative of tangent. So let's see here. Oh my gosh. This is our derivative of tangent. So we have f prime of x equals, I don't know, it's not one of my rules, but I can write tangent as sine of x over cosine of x. So, therefore, to get the derivative of tangent, it's going to be the low cosine of x, d high, derivative of cosine is cosine of x, minus high sine of x, d low, the derivative of cosine is negative sine of x. Yeah, I'm starting to see something up top here. All over the bottom squared. So my derivative, this becomes cosine squared of x plus sine squared of x all over cosine squared of x. Now at this point people are like, I can rewrite these. Don't do that. Watch. What did the whole top just equal to? Well, we know the Pythagorean theorem is that's just 1. That's my Pythagorean, that's just 1 over cosine squared of x, and that's just secant squared of x. And that's a rule for us. Okay? The derivative of tangent of x is secant squared of x. And that's something you have to memorize. Okay? Alright. I hope we're doing okay right now. So let's see here. The next one we're going to take a look at is the following here. This is a monster problem. Okay? I want you to go to my next video and watch this one. You will see this one on a test. You will see this on a quiz. Okay, so you're going to see this one over and over again. Okay, so go to my next video and watch that one.